Hello, Year Nines, me again. We got our second lesson about some revision today. I realized that the little booklet that I made for you had a bunch of data revision on it, but I didn't do that in yesterday's lesson. Also, I feel like I ended up talking for way too long. I didn't really want to talk for that long. So I've got some questions here just about data handling. The only things that I haven't really covered are, like I said, algebra, because you've done a bunch of that. There is a little bit in the starter today. And then we also didn't really cover loads of stuff on fractions. I assumed that you were okay with adding and subtracting and multiplying and dividing fractions, but if you're not, again, you can come and find me in the maths office. That's not a problem. And then that little booklet that you got given in class yesterday, hopefully you have that with you again today, because that is loads of questions for you to be doing to get ready for your test this week. Miss Kang is going to put the answers to that on the Google Classroom, and I'm also going to try to attach them to the cover work for today as well. Okay, and again, if you have any questions, just come and see me in the maths office at some point in time. So we're going to do a few questions on data handling. We're going to look at some cumulative frequency graphs, a box plot, and a histogram. You may have skipped some of those during your lessons. If you did, it's okay. If you already know about them, also cool. So we have about 5 slides today. We're going to do the starter. Ideally in your exercise book. If you don't have your exercise book on a whiteboard, it's also okay. So if you want to go ahead and pause the video now, and then come back and I will do the answers as well. All right, so they're going to ask us to work out -5 times -2. A negative times by a negative is going to make a positive, and 10 times by 2, not 10 times by 2, 5 times by 2 is 10. 30% of -270. It's the same as trying to find 30% of just 270. It's just our answer is going to be negative. So if we want to find 30%, we're going to start with 10. 10% is 27. And then if we want to times that by 3 to get to 30%, we can times the 27 by 3 as well. That's going to give us 81. So our answer is going to be -81, because both of those numbers should have also been negative. 2 cubed plus 3 squared, that's going to be 8 plus 9. 2 cubed is 8 because it's 2 times 2 times 2 again. 8 plus 9 is going to give us 17. 17 times 2.4, so I would do that as 17 times 24. 17 times 4 is 28. Carry the 2. 4 times 1 is 2, or is 4 plus 2 more is 6. 0, 14. Add that together. So I'm thinking that's going to be 408, but we have 1 decimal in the question, so we are looking for 1 decimal in the answer, so 40.8. And then 70 divided by 0.5, so you can think about this as a fraction, 70 divided by 0.5, and then I would actually double both of these. So if I double the 70, I'm going to get 140, and if I double the 0.5, I'm going to get 1. So this question is actually just asking us for 140 divided by 1, which is 140. To write 0.8 as a fraction, the easiest thing to do is write 8 out of 10, but you can simplify that and write 4 out of 5. This question doesn't say a fraction in its simplest form, so 8 out of 10 is also appropriate. The lowest common multiple of 6 and 16. In a test, you'd probably have a little bit more space than this, but the lowest common multiples, we're going to write the multiples of 6. 6, 12, 18, 24, 30, 36, 42, 48, 54. And then let's try 16, 16, 32, 48, 64. All right, 48 looks like it's in both of them. That looks like the only one that's common to both of them. So the lowest common multiple is going to be 48. The highest common factor of 45 and 99, I already know that both of those have 9 in common. That is the biggest number. So 45 has 1, 3, 5, 9, 15, and 45. And if I look at those and I think to myself, which of those go into 99? 9 is the biggest one. If I need to expand this, I need to multiply this x across both parts of this bracket. So x times by 2x is 2x squared, and x times by -3y is -3xy. If you put -3yx, that would also be all right. To factorize, so I would actually like this question to say factorize fully, which means take out the biggest number that's common to both of them. So 16 and 24, they have 2, 4, 8, they have all those numbers in common. I want to try to take out the biggest number, which in this case would be 8. X and Y don't have anything in common, so I can't factorize anything out of those. So I take an 8 out, and then I ask myself, what times by 8 makes 16x? And that's 2x. And what times by 8 makes 24? That's 3, so 3y. That's the best answer I could have. It would also be acceptable to write 2 bracket 8x plus 12y, or if you factorized out a 4, 4 times by 4x plus 6y. Okay, either of those would be appropriate, but I prefer the question to say factorize fully. All right, let's have a look at some of these data questions. All right, in a box plot, we essentially have 5 numbers and we need to plot them into a little picture. And the picture is going to be a rectangle. And we've got, in our rectangle, we have our lower quartile on the left-hand side of our rectangle and our upper quartile on the right-hand side of our rectangle. And then somewhere in the rectangle, doesn't matter how far through it is, we have the median, which is halfway. And then we have 2 arms on the box plot. They can be different lengths. And then we have on one side the minimum value, and then on the other side the maximum value. And all we have to do is draw those 5 lines and join them up. So on Friday, Peter went to the airport. He recorded the number of minutes that a bunch of planes were delayed, and he used his results to work out the information in this table. So he figured out the shortest time that a plane was delayed was 4 minutes, the lower quartile was 14, the median was 26 minutes, the upper quartile was 30 minutes, and the longest time that a plane was delayed was 57 minutes. They want us to draw a picture of all of this, so let's go ahead and do this. Across the scale on the bottom, we've got 0, and then 10, 20, 30, 40, 50, 60 minutes. And if you count all the little squares, there looks to be 10 tiny little squares in each section. So each little square represents 1. So I'm just going to make dashes at all of these different numbers right here on the axes down below. So the shortest time is 4. So here's 0, 1, 2, 3, 4. There is going to be my lowest time right there. Okay, I don't need any of the other little dots that we got there from counting. Now I've got my lower quartile. That's going to be 14. So here's 10, 11, 12, 13, 14. Okay, ideally you're going to do this with a ruler, and we'll keep going from there. The median is 26. So 21, 2, 3, 4, 5, 6. And then we've got the upper quartile is at 30. And the longest time was 57, so I'm going to count backwards from 60, 59, 58, 57. Okay, you join up the middle 3 in a nice rectangle, again, probably with a ruler, and then you draw the arms out to the sides. And that's about it. That's all they're looking for on that. That is usually 2 or 3 marks that they're looking for on these kinds of questions, and you get a mark if you make all of the correct ticks and join it up properly. All right, let's go ahead and look at cumulative frequency. So I'm going to break this into 2 different slides just so you get an idea. Plus, it's really complicated to try to fit it all on one screen. So here's just what they would ask us in part A of a question. So the table shows some information about the ages of 240 people in a club. And it says from 15 to people who are aged between 15 and 20, there's 95 people. And then the people aged between 20 and 25, there's 90 people. People aged between 20 and 30 is 35 people. There is between ages 30 to 35, there's 15 people. And then there's 5 people who are aged between 35 and 40. Part A of our question just says complete the cumulative frequency table. Cumulative frequency really just means add up as you go. You can also figure this out by reading the information that they're asking about. So in this first bit right here, they said how many people are aged between 15 and 20? Well, just like it says over here, 95 people are aged between 15 and 20. Now the next little bit is slightly different. The next bit of the cumulative frequency table says how many people are between 15 and 25. So these people right here are between 15 and 25. They're between 15 and 20. But the next group of people are also between 15 and 25. So we're actually looking to add these 2 numbers together. So that's going to give us 185. For our next one, we have to do kind of the same thing, but again, reading as it goes. We're just really adding on, but if you want to look at what we're actually doing, it says how many people are between age 15 and 30. Well, these people are, and so are these people, and so are these people. So this time we want to add in all three of those numbers. But we've already added on 95 and 90, so we can just add on the next lot of numbers as well. So to get to the next bit, I'm just going to add on 35. So that's going to give me 220. And then for the last two, I'm just going to, again, keep on adding on. It says how many people are between 15 and 35. Now I'm going to add on the next 15. That gets me to 235. And then finally, how many people are between 15 and 40? I'm going to add on those last 5 people to get me to 240 people. Now, it's always good to check this. We got a total of 240, and in the question, they actually said there was 240 people. So I must have done it correctly. All right, the next slide is going to look at how do we plot this, but it's going to be a different table because I just happen to have a different table ready. Okay, here we go. So usually there would be like a part B to the question, and they would say, now that you've completed the cumulative frequency table, they want us to go ahead and draw this. So it says on the grid, draw the cumulative frequency graph for this table. Now, a lot of people get confused as to what numbers we need to actually plot. We're looking for a bunch of points that we have to plot. And if you look right here, all of those numbers are 0. So they're not going to be very important to us at all. So we can actually scratch them out because they're completely unimportant. And all that we're left with is these numbers here. So if we put brackets around it, it says our first point that we're going to plot is 20 across the bottom for the amount spent, which is what it's got up there, over there. And then up the side goes up to 18 on the cumulative frequency. The next one, we've got up to 40 people or up to 40 pounds, sorry, and there's going to be 40 people that are up to 40 pounds. And then the next one, we've got up to 60, and that is 75 people. So these are all coordinates that we're going to plot. I like to scratch out that first column or at least put brackets around the two numbers so it helps me remember that I'm going to plot these as coordinates. All right, we're going to try our best to draw this as accurately as possible. So amount spent is across the bottom. I'm going to go across to 20 and then up to 18 people. So in this case, the cumulative frequency is telling me about how many people spent a certain amount of money. So there's my first point. My next one is 40 across and 40 up. And then the next one is 60 across and 75 up. So that point right there is 70, so about halfway. And then 80 across and 90 up, 100 across and 98 up, and 120 across and 100 up. From there, I'm going to join these points together, making a smooth curve. So in my cumulative frequency graph, it's very often called a cumulative frequency curve. So you want this to be a curve as smooth as you possibly can, joining a nice curve through all of those points. You can finish just like that, or if you'd like to, you can continue to go back through 0. That one is your choice. Usually there's a second part to the question, like a part C, where they say, could you work out what is the median amount of money spent? Okay, so this question has 100 people in it, and if I'm looking for the median is going to be halfway through. So the median, if there's 100 people, 100 divided by 2, we'd be looking for the 50th person. So I want to find the 50th person. The cumulative frequency tells me how many people this is. So if I'm looking for the person, let me see if I can get a straight line somewhere on here. Looks like I don't remember how to do that. We'll try to do our best. All right, so we're looking for the 50th person. The 50th person is right here, and I want to find out how much money they spent. I use my ruler to make a straight line all the way over to that graph. And then once I get to the curve, I'm going to draw a straight line all the way down as best I can and find out what value that is. That looks like it is 44 pounds. So the median amount of money spent was 44 pounds. And that's because I found the 50th person and then found out how much money they spent. All right, one last topic. We've got some histograms to do. I'm going to go over how you draw a histogram. All right, last little bit from me. So we're going to look at how to draw a histogram. Lots of people, I feel like, are going to tell you lots of different things about histograms. For me, I try not to remember any particular formula. I just think about histograms being areas of rectangles. So I'm going to draw 1, 2, 3, 4 different rectangles to make my graph. And the only thing I really need to worry about is that the frequency is not going to tell me the frequency. This is going to tell me the area of each of the rectangles. And then over here, this is going to tell me the width of the rectangle. So let's read the information first. It gives us information about the number of hours worked by some factory workers. Okay, so at first it says we've got 15 people worked somewhere between 0 and 5 hours. So 0 to 5, that is a width of 5 and an area of 15. Well, if I drew that as a rectangle, I've got an area of 15 and a width across the bottom of 5. How do I find the height? So I'm going to try to find another column over here, which is called the height, which the actual name for it in histograms is frequency density. All right, that's what's going to go up the side of this table over here, or the side of that graph over there. But really all it is the height of the rectangle. So if I wanted to find this question mark over here, I would have 5 times by something, that is the area of a rectangle, is going to give me 15. So my unknown bit, my height or my frequency density, is going to be 3. And that's from 15 divided by 5. So this frequency density is going to be 3. All right, let's do the next one. We'll change colors as well. So the next one, we're going to draw another rectangle. And in my next rectangle, it has an area of 42 this time. And the width across the bottom is going to go from 5 to 15, which is a width of 10. Okay, I got that by doing 15, take away 5. So I want to find out how tall this is going to be, or the height. So 10 times by something gives me 42. So my question mark is going to be 4.2. My frequency density, or my height, is going to be 4.2. Moving on to the next one, we'll change colors again. So we've got another rectangle. This time it has an area of 40 because the next frequency is 40. The width across the bottom goes from 15 to 30, which is 20. And I want to find out how tall it is. So 20 times by something gives me 40. So that number I'm looking for is 2. The height of this green rectangle, or the frequency density, is going to be 2. And then lastly, we have our final rectangle. It has an area of 6, and it goes from 35 up to 15. So that is a width, goes from 35 up to 50. So that's a width of 15. So this one's going to be a really funny decimal. So this time I have 15 times by something is going to give me 6. Let's see, 6 divided by 15, because we got to do this without a calculator on Friday. 6 divided by 15, those can both be divisible by 3. So that's 2/5, which is 4 out of 10, which is 0.4. That's how I would do that on Friday if I didn't have a calculator. All right, so the height of this one is going to be 0.4. And now all we have to do is draw these 4 different bars. So we're going to look at the width, and we're going to look at the height, and we're going to draw them. And you know what? We'll go ahead and color code them. So it says the first rectangle that I want to draw, we've got our numbers of hours down here. So our first rectangle is going to go from 0 to 5. So it's going to start here, and it's going to finish here, and it's going to have a height of 3. Now I do apologize. I don't know how to get a straight line on this on the program that I'm using. So you should use a ruler. I know that I'm not, but we're going to use our imaginations. All right, so there's my first rectangle. It's got an area of 15, or a frequency of 15. It's got a width of 5 across the bottom and a height of 3. All right, on to the red one. The red one starts at 5 and it finishes over here at 15. It has a height of 4.2. So that's going to finish all the way up here. And again, we're going to try to use our ruler. Well, you'll use your ruler. I just can't do that on here. So there's my next one. The next one I'm moving on to is the green one. So it starts at 15 and goes all the way up to 35. And it has a height of 2. And then lastly, we go from 35 all the way up to 50. And this one has a height of 0.4. So that is just these tiny little squares here. And there we go. So even though it looks a little bit dodgy because all of them are not quite straight lines, it's still, we need to use our imagination in these. Now, the thing with histograms is that the area tells us about the frequency. So, whichever shape has the biggest area actually has the highest frequency. So, that's really, really important in looking at that because, for instance, this blue bar right here looks really, really tall, but the blue bar only represents 15 people. And the reason why it only represents 15 people is because it has an area of 15. But the green rectangle has an area of 40, even though it's a lot lower, right? It only goes to as high as 2, but it's a much bigger area. So the green one represents a much bigger amount of people overall. All right, even though we only had like 4 examples, I feel like I ended up talking just as long as I did yesterday. So hopefully you're feeling a little bit better about your test for Friday. Again, like I've said so many times, if you have any questions, please do come and find me in the maths office. And you're also going to do the rest of that booklet now, and we will continue that later. All right, bye.